Good evening. I am G. Karan Kumar, working as a lecturer in Electrical and Electronics Engineering, Institute Government Polytechnic Yadagiri, year first semester. Today I am teaching the subject nothing but basic electrical engineering, that is a subject code E105. Topic series and parallel resistance circuits. Subtopic series and parallel combination. Again we studied in the case of series combination. Again we can say it is nothing but the where two or three resistors are connected in the series. Again we can say it is nothing but the series combination where the voltage can be applied here. We can say it is R1, R2 and R3. Current I, again no voltage we can apply here. Again the parallel resistance circuit is nothing but the two or three resistors are connected in the parallel. We can connect the two resistors are connected in the parallel, we can say it is the parallel resistance. Again the case of series combination, again we can write here the conditions are nothing but the current remains the same and the voltage can be divided. Again the case of parallel combination, the current can be divided, voltage remains the same here. Again now we see the subtopic series and parallel combination. Series circuit and parallel circuit, the circuit current is the same, voltage is the same. Again I is equal to I2 is equal to I3, V1 is equal to V2 is equal to V3. Individual voltages are added, individual currents are added here. Again we can say here Vt is equal to V1 plus V2 plus V3 and It is equal to I1 plus I2 plus I3. Total resistance, total conductance, total resistance RT is equal to R1 plus R2 plus so on up to Rn. Total conductance GT plus G1 plus G2 plus so on up to Gn. I is equal to I1 is V1 by R1 is equal to V2 by R2. Again V is equal to I1 by G1 is equal to I2 by G2. Again we can say the conductance is nothing but the reciprocal of the resistance here. So these are the comparison of series and parallel circuit. Again in the case of series circuit the current equal. Again in the case of parallel circuit voltage remain the same. Again in the case of series circuit voltage can be divided. Here the current can be divided. Total resistance, that is RT is equal to R1 plus R2. Here the total conductance, that is the GT is equal to G1 plus G2. Current I is equal to V1 by R1 is equal to V2 by R2. V is equal to I1 by G1, I2 by G2 here. So duality, while comparing the series and parallel circuits, the voltage takes the place of current and current takes the place of voltage. The pattern is known as a duality. The two circuits are said to be duals of each other. Again on completion of this period you would be able to find the equivalent resistance in series and parallel circuits. Total current flows in the circuit series and parallel combination. Resistance in series and parallel combination. Sometimes the circuit may be neither pure resistance or pure parallel. The combination of series and parallel circuit as shown in figure given below. Again here the two resistors are connected in the parallel, where the parallel combination is connected in the series with the resistance, where we are applying the voltage V. Here whenever by applying the voltage V, the current can be flows again across the two resistors, that is R1, R2 and R3 here. So here the parallel combination can be connected means the current can be divided. That is the current we can say here I1. Here the I1 can be flows. Here the I2 can be carries it. So whatever the current that can be flows across the R3 is nothing but the I here. So again we can find I1 is equal to again here V1 by R1, I2 is equal to V2 by R2. Again here current I is equal to V by R3. So the first the parallel combination resistance R1 R2 should be solved for equivalent resistance RE. So that is nothing but the two resistors are connected in the again parallel. So we can find R equivalent for R1 R2, R1 R2 by R1 plus R2. So 1 by R is equal to 1 by R1 plus 1 by R2. So that is R is equal to R1 R2 divided by R1 plus R2. So resistance in series and parallel combination. The equivalent resistance Re and R3 form a series circuit as shown in figure 2 given below. That is, the R equivalent is comes in series with the R3 where the voltage can be applied and the current can be flows. So that is thus the total resistance is Re plus R3. Therefore, the total resistance of the series and parallel circuit is Re plus R3. Therefore, the current I is equal to V by Re plus R3. Problem 1. A resistor of 30 ohms is connected in parallel with the resistor of 60 ohms. In series with the parallel combination is a 20 ohm resistor as shown in figure. What is the resistance of entire circuit? So here the two resistance are connected in the parallel, that is the 30 ohms and 60 ohms are connected in the parallel. The parallel combination is comes in series with the again 20 ohms resistance. That is again R1 is equal to 30 ohms, R2 is equal to 60 ohms, again R3 is equal to 20 ohms, R equivalent is equal to how much? So first we can solve here R equivalent, that we can write here, that equivalent is nothing but R4. It is nothing but the R1 R2 divided by R1 plus R2. So that is again here. So therefore R, we can assume here R4 is equal to nothing but 60 into 30 divided by 60 plus 30. So we get some value here. So that R4 is comes in series with the 20 ohms resistance. So we have to add, again we get the R equivalent. The equivalent resistance of the parallel combination is Re. That is, Re is equal to R1 R2 by R1 plus R2, which is equal to 30 into 60 by 30 plus 60, which is equal to 1800 by 90, which is equal to 20 ohms. So Re is in series with the R3. Therefore, the RT is equal to Re plus R3, which is equal to 20 plus 20, that is equal to 40 ohms. So the total resistance of the circuit is RT is equal to 40 ohms. So two resistors R1 R2 are connected in the series across a 100 volts supply takes a current of 5 amps, and when they are connected in parallel across the same supply they take a total current of 33 amps. Find their values. Given data. Then supply voltage is 100 volts. Two resistors are R1 R2. When they are connected in series, I is equal to 5 amperes. When they are connected in parallel, I is equal to 33 amperes here. Again, R1 R2 is equal to how much? So here I is equal to V by R equivalent, which is equal to V by R1, V divided by R1 plus R2. So R1 plus R2 is equal to V by I. Again here R1 plus R2 is equal to 100 by 5. So this is this one for the series. So where the two resistors are connected in the series here, that is a R1 and R2. So these can be added, R1 plus R2 here. So that is R1 plus R2 is equal to 20 ohms. I is equal to V by R1 R2 by R1 plus R2. R1 R2 by R1 plus R2 is equal to V by. So this key we can take the parallel combination. That is the two resistors are connected in the parallel. R1 and R2, which is equal to 3.333 ohms. From equation 1, R1 plus R2 is equal to 20 ohms. Substituting in equation 2, again we can get R1 by R2 plus 20 is equal to 3. R1 R2 is equal to 60 ohms. So that is equal to R1 minus R2 square is equal to R1 minus R2 square minus 4 R1 R2. Then we can, which is equal to 20 square minus 4 into 60. 400 minus 240, that which is equal to R1 minus R2 square is equal to 160 ohms. So R1 minus R2 is equal to under root of 160, that is a 12.6 ohms. So R1 plus R2 is equal to again 20 ohms. Again R1 minus R2 is equal to 12.6. Again we have, if we solve, we get minus 2R1 is equal to 32.6. R1 is equal to 16.3 ohms. From equation 1, R2 is equal to 20 minus R1 is equal to 20 minus 16.3. So R2 is equal to 3.7 ohms. Problem 3, the circuit given below, find the total resistance, total current here. So given where the, again 3 and 4, the resistance are connected in the parallel. Again this parallel combination connected again parallel with the 2, 8 and 6 ohm respectively. First we have to do the parallel combination, that is the 3 and 4. The 3 and 4 are connected in parallel between A and B. Hence resistance between A and B is RAB is equal to 3 into 4 by 3 plus 4, which is equal to 12 by 7, which is equal to 1.7 ohms. Again here AB, again 3 and 4, here 1.7 ohms. Again this 1.7 ohms is connected in series with the parallel combination 2, 8 and 6. Again 20 volts. Again 2 and 8 is parallel between B and C. Hence resistance between B and C is RBC is equal to 2 into 8 into 6 divided by 2 into 8 plus 8 into 6 plus 6 into 2. Again we get, which is equal to 96 by 16 plus 48 plus 12, that which is equal to 96 by 76, that which is equal to 1.263 ohms. So therefore here RAB and RBC are in series between A and C. Again hence resistance between A and C is RAB. So RAC is equal to RAB plus RBC. Again we get, which is equal to 1.7 plus 1.263, we get, which is equal to 2.963 ohms. So total resistance of the circuit is 2.963 ohms here. So total current V by RAC 20 by 2.963, which is equal to 6.75 amperes. So summary, we have discussed equivalent resistance in series and parallel combinational circuits. Again here solve problems on the series and parallel combinational circuits. And two resistance 3 ohms and 6 ohms are connected in parallel with a series combination of 1 ohm resistor. The equivalent resistance of the whole combination is 3 ohms, 5 ohms, 12 ohms and none of the above. Again connected in the parallel, again we can do the parallel combination, that is a 3 into 6 by 3 plus 6, which is equal to, we can get the answer is nothing but the, again here 9 2s are 18. So 2 combination comes in series with the 1 ohm resistor, we can get 2 plus 1, which is equal to 3 ohms. So frequency questions are nothing but the resistance. The resistor of 1 ohm 10 ohms is connected in parallel with resistor of 220 ohms in series. Series with the parallel connection in the 30 ohm resistor. What is the resistance of the entire circuit? A resistor of 10 ohms is connected in parallel with the resistor of 220 ohms in series, full stop, in series with the parallel connection in a 30 ohm resistor. What is the resistance of the entire circuit here? So again we can assume here 10 ohm resistor is parallel with the resistor of 220 ohms. The 30 ohm resistor What is the resistance of the entire circuit? It is a 10 ohms and 220 ohms are connected in parallel. This parallel combination comes in series with the 30 ohms resistor. So resistor of 10 ohms is connected in parallel with resistor of 220 ohms in series with the parallel connection in a 30 ohms resistor. So 10 ohms and 220 ohms are connected in parallel. Parallel combination comes in series with the 30 ohm resistance. Again, in this way we have to do. Then we have to find out the total resistance. First we have to do the parallel combination. Then this parallel combination comes in series with 30 ohm resistance. Again, we have to add here. Again here that subtopic we can study here, problems on series and parallel combination. So in the previous class we have discussed equivalent resistance in series and parallel combination circuits, total current flows in the circuit with the series and parallel combinations. So on completion of this period you would be able to calculate equivalent resistance in series and parallel combination circuits, total current flows in the circuit series parallel combination. So here 6 resistances are connected as shown in figure given below. Find the current through the 2 ohms resistor. Here nothing but 3 ohms and 5 ohms and 8 ohms are connected in parallel. So this parallel combination comes in series with the 7 ohms resistance. Again these parallel combination can again connect to the 9 ohms resistance. Again the series combination is 2 ohms here. So first we have to do the nothing but the A and C, that is across the branch A and C. 3 ohms, 5 ohms and 8 ohms are connected in parallel. First we have to find the R equivalent for this one. Again next we have to do again the C and D, across the C and D branch 7 ohms resistance can be connected. So this resistance comes in series with the A and C. Again we have to add. Again AD resistance can be comes in parallel with the 9 ohms. Again we have to do parallel. Again this A and D resistance comes in series with the D and A. Again we have to add. Again we have to find out the total current here. First step 3, 5, 8 ohms are in parallel. Therefore the equivalent resistance R equivalent is equal to 3 into 5 into 8 divided by 3 into 5 plus 5 into 8 plus 8 into 3 here. So which is equal to 120 by 15 plus 40 plus 24, which is equal to 120 by 79. So R equivalent is equal to 1.52 ohms. So next R equivalent and 7 ohms are in series. So therefore total resistance RT is equal to 1.52 plus 7, which is equal to 8.52 ohms. That is equal to 8.52 and 9 ohms are in parallel. So therefore the total resistance RPT is equal to 8.52 into 8 by 8.52 plus 9, which is equal to 4.38 ohms. So 4.38 and 2 ohms are in series. So therefore RAE is equal to 4.39 plus 2, which is equal to 6.38 ohms. So the equivalent resistance of the circuit is 6.38 ohms here. So voltage across 12 ohms and current through 2 ohms resistor is 12 by 6.38. So sorry, the current through the current through 2 ohms resistor is 12 by 6.38, 1.88 amperes. Next, here find the total resistance of the circuit. First given below. First we have to do the again 2 and 8 is comes in parallel. That is again we have to do 2 into 8 divided by 2 plus 8. Again this comes in series with the 2.4. Again we have to add. Again we have to do parallel with this one. Again here parallel combination comes in series with this one. Again we have to do parallel. Again series. Again we have to find the entire resistance here. Where 2 and 8 ohms are connected in parallel, so between A and B. Therefore RAB is equal to 2 into 8 by 2 plus 8, which is equal to 16 by 10. RAB is equal to 1.6 ohms. RAB and 2.4 ohms are in series. 1.6 plus 2.4 is equal to 4 ohms. 4 and 6 ohms are in parallel between A and C. Total resistance is equal to 4 into 6 by 4 plus 6. RAC is equal to 2.4 ampere, 2.4 ohms. So RAC is equal to 2.4 ohms. Again this combination comes in series with the 3.6. Now the circuit is condensed as 2.4 ohms comes in series with the 3.6. Again we have to add here. Again this series combination comes in parallel with the 4 ohms resistor across the A and D. Again comes in series with across the D and E. Again we have to find out the total resistance. So that is 2.4 and 3.6 ohms are in series. Total resistance is equal to 2.4 plus 3.6, which is equal to 6 ohms. Six and 4 ohms are in parallel, so between A and D. Therefore RAD is equal to 6 into 4 by 6 plus 4, which is equal to 2.4 ohms. 2.4 and 5.6 ohms are in series. Total resistance is equal to 2.4 plus 5.6, which is equal to 8 ohms. So total resistance of the circuit is 8 ohms. Find the equivalent resistance and the current flows through the circuit given below. That is the first we have to do the again 3 and 7 ohms are connected in parallel. We have to do the again parallel combination. This parallel combination comes in series with the 3.9 ohms resistance. Again we have to add both the resistance. Again we have to do in parallel with this one. So 3 and 7 ohms are in parallel between B and C. Total resistance RBC is equal to 3 into 7 by 3 plus 7. Again we get RBC is equal to 2.1 ohms. So step 2 again 3.9 and 2.1 ohms are in series between A and C. Total resistance is equal to 3.9 plus 2.1. RS is equal to 6 ohms. Six and 4 ohms are in parallel between A and D. Total resistance RAD is equal to 6 into 4 by 6 plus 4. Again we get which is equal to 2.4 ohms. Again here equivalent resistance of the circuit which is equal to 2.4 ohms. Again here current flow through the circuit which is called V by RAD. Again which is equal to 24 by 2.4, which is equal to 10 amperes. Problem 4 here. Here find the equivalent resistance of the and the current flow through the circuit given below. Here where 2.4 ohm resistance A and B connect across the branch, and across the B and C 2 ohms and 8 ohms are connected in parallel, and across C and D 4 ohms, 1 ohms and 2 ohms are connected in parallel. So first we have to do the parallel combination. Again, that is the 2 into 4, and next we have to do the 4 ohms, 1 ohms and 2 ohms. So all this 2.4, this resistance and this resistance comes in series, and we have to add all the three resistance. Again we have to find the total current I. So here 2 and 8 ohms are in parallel between B and C. So therefore RBC is equal to 2 into 8 by 2 plus 8, which is equal to 1.6 ohms. 2.4 and 1.6 are in series between A and C. RS is equal to 2.4 plus 1.6, which is equal to 4 ohms. So 4, 1 and 2 are in parallel between C and D. Then RCD is equal to 4 into 1 into 2 divided by 4 into 1 plus 1 into 2 plus 2 into 4. Again we get 8 by 14, which is equal to RCD is equal to 0.57 ohms. 4 and 0.57 ohms are in series. Equivalent resistance of the circuit, which is equal to 4.57 ohms. Current flow through the circuit, which is called I is equal to V by R equivalent, which is equal to 60 by 4.57, which is equal to 13.13 amperes. So we have solved problems on how to calculate the equivalent resistance in series and parallel combination circuits. Total current flows in the series parallel combination circuits is what is the equivalent resistance of the circuit if 1 ohm resistance is connected in series with the parallel combination of two ohms resistors. Again here the 1 ohm resistor is connected in series with the parallel combination of two ohms resistor, that is a you can say it is a 1 ohms, it is a 2 ohms, it is a 2 ohms resistor. Again we can do here 2 ohms are connected in series, that is a 4 divided by 4 1. Again we get the answer is nothing but the 0.3. 0.2 ohms here. Again it is nothing but the again 1 plus 2 into 2 divided by 2 plus 2. Again 1 plus here 4 by 4, it is 1. You get the answer is 2 ohms. So frequent questions are find the current through 7 ohm resistance of the following circuit. Again here 3 ohms, 5 ohms and 6 ohms are connected in parallel, 7 ohms and 9 ohms and 2 ohms, which is connected to the 2 ohms voltage here. So we have to find the current through the 7 ohms resistance. Thank you.